Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, so for today's lesson, we are going to take a deeper dive into converting decimals into fractions. The previous lesson we had was going in the other direction. How do you change a fraction into a decimal? And we learned that you do it by dividing. And we analyzed why sometimes the decimal number repeats and sometimes it terminates. Okay, so today we're going to be starting off with the terminating decimals because it's a pretty simple process to write them in fraction form. However, when you've got a repeating decimal, it's not so easy. So today is a day where I'm going to, number one, have you looking at patterns, but the pattern doesn't always work. So I am going to show you a strategy that can be used to convert a repeating decimal into a fraction. So let's get to it. Let's start with this. In lesson 2.1.1, you worked with different fractions and found ways to rewrite those fractions as repeating and terminating decimals. In this lesson, you'll reverse your thinking and will instead represent decimals as fractions. As you work today, ask yourself these questions. How else can I describe the portion, and how many pieces are in the whole? So remember, this is the representations portion. It's like a portions web where it's basically showing that you can rewrite any fraction as a decimal or percent. And of course, since you can say the name of the fraction, you can say it, you're using words. So words and pictures can also describe those fractions. So, you know, if we were to take 3/4. 3/4, if you do the division, is the same as 75 hundredths. 75 hundredths by definition is 75% because that's what percent means, a quantity out of 100. And you could either say 3/4 in word form, or you could draw a picture where 3 of the 4 sections are shaded in. Okay, so being able to go back and forth between these representations is really important. For instance, if you're given information about a percent and you need to do some calculations, you'll need to convert that percent to either a fraction or a decimal, most likely decimal because we like to use calculators. Sometimes you're given a decimal number and you need to use proportional reasoning, and it's nice to see that decimal as a fraction. Okay, so we can go back and forth between these. No, I shouldn't say we can. We're learning how to do it because we need to be able to go back and forth between those representations of portions. Okay, so this is what I would like for you to do. I would like for you, here's an example of a of 2/3 is 0.6 repeated, which is 66 2/3%. What we're going to do is copy down, or you are going to do it, I've already done it, copy down each one of these representations of a rational number. And then your job is to rewrite it as a decimal, as a percent, as a word, or as a fraction. You're given one representation, you fill in the other 3, okay? So please do problems A through E. Pause the video, write these down, and then I will show you what the answers are, and hopefully you're getting everything correct. Okay. Welcome back. Hopefully you did everything perfectly. Let's see what we've got here. 7/10. One of the nice things about fractions is a lot of times, well, no, forget that. I'm going in a different direction. In this particular fraction, 7/10 also describes the name of the decimal number because it's got a 10 in the denominator. So 7/10 would be 0.7, also called 7/10. And 7/10 is the same as 70 hundredths, so that would be 70%, and we'll just call it 7/10 because that's what the fraction says. This number is 75 hundredths because remember how we name decimal numbers? The last digit is in the hundredths place, and the entire number that we can see there is 75, so we'll call it 75 hundredths. 75 hundredths by definition is 75%. So those are the 3 representations for this decimal number. 3/5. How would I write 3/5 in fraction form? Well, 3/5. Now, it turns out 3/5 is the same as 6/10, which is 6/10, so that would be the decimal form. And 6/10 is the same as 60/100. We can write that as 60%. And then our last decimal, or our last fraction, is 5/8, which when you do the decimal ends up being 0.625 or 625 thousandths. Now, this is the one, these others were pretty simple to convert to decimal numbers and convert to percents. This one's a little bit trickier because there is a rule that we have to learn about moving the decimal to the right or moving it to the left, and we'll get to that in a future lesson. I think you've already been taught that. I know I used to teach it in 5th grade, so I'd imagine you've gotten it by now. But we'll go over it again. You know, it's nothing wrong with repeating and making sure that that we cover all of these concepts thoroughly. Okay, so 625 thousandths is 62.5%. 5/8 was the name of that fraction. Now, let's go back to problem B. Explain how you rewrote 75 hundredths as a fraction. Is there more than one way to do it? And that is there more than one fraction that can be used here to represent this decimal number? And the answer is yeah, absolutely, you could do that. 75 hundredths is 75/100, but you could also simplify that fraction. So you could call it 3/4, 6/8, 30/40. There are an infinite number of equivalent fractions, but I would always go with the simplest version of it, which would be 3/4. Okay, so since 0.7 is described as 7/10, it's not a surprise that the fraction equivalent would be 7/10, right? 7/10, 7/10. Obtain a set of decimal cards. No, you're not doing that. Let's just jump right down to here. What I want you to do is I want you to say the name. First of all, write down each one of these numbers and say their name. And remember, when you say their name, you say the number, and then you identify the place that the last digit is in. So for instance, this number is 19, and the 9 is in the hundredths place, so that's going to be 19 hundredths, okay? So do the same with B, C, D, E, and F. And then you can pull out your calculator and do the division. Is 19 divided by 100? 19 divided by 100 equal to 0.19? Yes, it is. So we know we've got that correct. Okay, go ahead and do that with all the others. Pause the video. All right, welcome back. Let's do this. I'm going to go ahead and underline each one of these last digits so we know what place these are in. So this is 391 with the 1 in the thousandths place, so that is 391 thousandths. This is a 1 in the thousandths place, so it'll be 1 thousandth. This is 19 with the 9 in the thousandths place, so this will be 19 thousandths. This is a 3 in the 10th place. So this fraction is going to be 3/10. And 524 with a 4 in the thousandths place is 524 thousandths. Okay, so pretty simple process converting any decimal number into a fraction. The only place where we would have an issue would be like 524 thousandths, having to simplify that fraction. Every one of these others, A through E, is in simplest form. So I'm going to go ahead, and we learned about the rules of divisibility in our last lesson. Let us simplify this fraction by using the rules of divisibility. First off, I know these two numbers are even numbers. So I'm going to see if how many times we can divide them by the number 2 to make them a little bit simpler. Remember, let's start with the 2, the 3, and the 5. Start with the prime numbers. See if we can go from there. So if I divide this by 2, 524 divided by 2 is 262. Is that right? Yeah, 262 over 500. And it looks like they're divisible by 2 again. And I should have noticed that, right? Since the rule for 4 was if the last 2 digits are divisible by 4, then the entire thing is divisible by 4. So we'll divide this by 2 again, and this is going to end up being 131. I can do this mentally. and that ends up being 250. And now, what are the rules here for 131? It's not an even number, so 2 doesn't go into it. 1 plus 3 plus 1 is 5, so 3 doesn't go into it. And it doesn't end in a 0 or a 5, so 5 doesn't go into it. If 2, 3, and 5 don't go into it, then I guess the only thing we can do is see if 7 or 11 or 13, right? Because those are the next prime numbers, and we don't even want to focus on the rules for those. I'm pretty sure that's in simplest form. So turns out 131, I'm pretty sure is a prime number. And anyway, if you look at the denominator now, 25 times 10 is going to be 5 times 5 times 5 times 2. So the only way we'd be able to simplify this more is if 131 was a multiple of either 5s or 2s, and it's not. So this would be the answer in simplest form. Okay, so that is a brief demonstration of how you can use your understanding of the rules of divisibility to help you simplify fractions. Okay, Jerome works at the fraction factory in the department that changes decimals into fractions. He's just received an order to rewrite 0.73 repeated as a fraction, and he started to write it like this, 73 over 100, but he's not sure if that's correct. Is 73 over 100 equal to 0.73 repeated? Okay, now this is a stoplight problem, right? So you know what this means. It means that there's a common mistake that people make here. And I'm going to tell you right now, once we get into this, the last page of this, last slide of this lesson is going to be showing how to convert 0.73 into a fraction, an equivalent fraction, and it's not easy, right? Nothing like going back and forth between the terminating decimals and the fractions. So, are they equivalent to each other? Go ahead and jot down your thoughts, and then I'll expose what I've written down. Why are they not equal to each other, basically? Okay, hopefully you got a lot of good information written down. I said no, 73 hundredths is 0.73. It's a terminating decimal. 0.73 repeated is a repeating decimal, so they are absolutely not equivalent to each other. All right, now you get to use your calculator. We are going to explore some patterns with numbers, and this is a great exercise, but it's not really a substitute for learning how to convert between repeating decimals and fractions, okay? Go ahead, copy each one of these down, and use your calculator to determine what is the decimal equivalent for each one of these fractions, okay? Come back when you're ready. All right, let's see what you got. 19 over 99 should have given you 0.19 repeated. 391 over 999 is 0.391 repeated, and 3 over 9 is equal to 0.3 repeated. So are you picking up on the pattern there? Every one of these situations has a fraction with only 9s in the denominator. Here's 99, there's 999, and here's a 9. Notice that the number of 9s in the denominator matches the number of digits that are repeating. And you notice which digits are repeating? The numerator in every single one of these cases. So if you used a calculator in these first few, you should have been able to pick up on a pattern and know what to write for the last. Now, there could be some mistakes. Like I've had students in the past that think this is 0.1 repeated. But remember, it's supposed to be 3 digits repeating. So that's 0.001, 001, 001. There's only 1 digit in the numerator, so you need 0 placeholders to get your 3 digits in here. Here you got 524. That's pretty straightforward. It's going to be 0.524 repeated. And this is kind of similar to problem D, whereas you got 3 digits repeating, but only 2 digits in the numerator. So you're going to need a 0 placeholder there. So you might see the patterns, but still it's a good idea to check and make sure that that's what you're getting with your calculator. So what connections do these fractions have with the ones that we found on the previous page? Or on problem 19, I should say? Well, they're very, very similar in that they have the same number of parts. but they're repeating, right? And so what we got for our answers in problem 19, you had the same numerators. Oh, you had the same, come on, dude, get out. There you go. You had the same, oh, there it is. Same numerators, but the denominators here were one less. So this, if it was 0.19, just 19 thousandths, you'd have 1,000 in the denominator, right? Or 100, I guess, 100. Here, if it would be 391 over 1,000 would have been the previous example, but here it's 999. So each one of our denominators is one less than the one that was similar to it in the previous problem, number 19. So use this pattern that we did here to see if you can predict what you think is going to be the fraction equivalent of 0.24 repeated, and then do the same thing for problem I, but go in the other direction. What do you think is going to be the decimal equivalent for 65 over 99? Think you got it? What's our fraction for 24 over 99? Or for, that's what it is, 24 over 99. Now you could simplify this. Remember our rules of divisibility. 24, 2 plus 4 is 6, and 3 goes into 6, so both of those are divisible by 3. So this would be the same as 8 over 33, right? 65 over 99, I'm not sure if that can be simplified. I think that's in simplest form. What's the decimal equivalent of that? 0.65 repeated. Okay, so this is wonderful when you've got this nice pattern where every digit is being repeated. However, there are some situations where that's not the case, and this pattern will no longer work. So therefore, we're going to explore a strategy, an algebraic strategy for converting repeating decimals into fractions. So go ahead, pause this, and copy down this label, get this nice and neat in your notes. And we're going to start with 0.73 repeated, since we already saw that as that one example for the stoplight problem. Okay, so a little bit of math background. One of the nice things about our numbering system, our decimal system, it's a base 10 system. Whenever you multiply number times 1, it's always equal to itself, correct? Whenever you multiply a number times 0, it's always going to be equal to 0. Well, 10 and 100 and 1,000, when you multiply any numbers times those numbers, you only have ones and zeros there. So essentially what happens is whatever, however many zeros there are in your power of 10, that's how many decimals you would move your decimal point over. So if I take like 0.737373, and oops, stop it, go back, 0.737373. If I multiply that times 10, you're going to just move the decimal one place to the right, but all the digits are going to stay the same. So times 10, and it's going to be 7.37373. So that's what we're going to do here. For this exercise, we're only going to multiply times 10 or 100 or 1,000. So we never have to do any multiplication. We're just moving the decimal the appropriate number of places. So if I took 10x's, if 1x is equal to 0.73 repeated, then 10x's would be multiplying this times 10, right? So you'd have to multiply this times 10. So that becomes 7.373737. Now notice that it's 37 repeating as our decimal. Well, what if I multiply to x times 100? Wouldn't that be now 100 x's? And since 100 has 2 zeros, that means you would move that 2 places to the right, so it becomes 73.737373 repeated. All right, so now what I'm going to do is I'm going to take this equation, and I'm going to take this equation, and I'm going to subtract 1 from the other. Watch that. I'm going to take 100 x's, and I'm going to subtract away 1x, leaving me with 99 x's. And here I'm going to take 73.73 repeated, and I'm going to subtract away 0.73 repeated. Now, you might be thinking, how can you do that? Aren't you supposed to, when you're adding or subtracting numbers, you're supposed to go to the far right digit and you're supposed to come down? And I would say, yeah, you are. But what's more important is that you line up your decimals. And in this case, you notice that any digit in the hundreds place, thousands place, millions place, any place value, they're always going to match up perfectly. So if we were to go to the end of infinity and just start working our way to the left, eventually we would get to this point where all of those would cancel out, leaving you with 73 minus 0 is 73. So how do we finish this process? Well, this is a multiplication statement, right? It's saying 99 times x is equal to 73. So according to our mathematics multiplication families, if you take this number times that number gives you this, then this divided by that will tell you what that number is, right? Let's go back to this problem. 2 times 3 is equal to 6. 6 divided by 3 will give you 2, and that's supposed to look nice and neat, and it doesn't. But that's the basic idea. And I'm sure Mr. Harbour has taught this to you, or your 6th grade teacher has taught this to you, that when you're solving an equation like this, you just divide both sides by this number 99. It essentially cancels out the 99s because it turns it into a giant 1, and 1 times x is just x, correct? But now we divided this by 99, and I'm pretty sure that's in simplest form. So 73 over 99 is 0.73 repeated, and then that fits in perfectly with this pattern that we were seeing over here. Okay. So this is the mathematical process that we use to convert repeating decimals into their equivalent fractions. Now let's try it again. You have seen this decimal number before, where 0.83, but the 8 isn't repeating, it's only the 3 that is repeated. Go ahead and copy that down. If I multiply x times 10, then it becomes 10x's, and we move the decimal one place to the right, this becomes 8.3 with the 3 repeated. If I were to multiply this x times 100, then this becomes 100x, and we would move the decimal 2 places to the right, and that becomes 83.333 repeated. Now in this case, these are the two equations that we want to work with, because these are the two equations where all of the digits line up perfectly in the decimal places. So we're going to take 100 x's and take away 10 x's to give us 90 x's, and then when we take 83.3 repeated and cancel out all of the decimal parts because they line up perfectly, then 83 minus 8 is 75. So let's finish this process. Let's see what fraction this is equal to. We're going to divide each side by 90, and while x is equal to 75 over 90, that is not in simplest form. Looks like both of them can be divided by 5, right? Because they end in either a 0 or 5. So 75 divided by 5 is 15, and 90 divided by 5 is 18. Okay, there's no more 5s. Can 2? No, 2 doesn't go into that. What about 3s? 1 plus 5, yeah, 3 goes into 15 and 3 goes into 18. So let's simplify this even further. 15 divided by 3 is 5. 18 divided by 3 is 6. So it turns out 0.83 repeated is equivalent to the fraction 5 over 6. Can I prove it? I bet I can. 5 divided by 6, there you go. Okay, so this is the process that we use. It's not something that you use every day. It's actually not very common for people to know how to do this. In fact, I'd be willing to bet that pretty much any adult in your life who's not a math teacher or doesn't have a career in engineering or something that is heavy with math wouldn't know how to do this and wouldn't even know it was possible to do this. But it is good to know, it's good to understand how these numbers work and how we can go back and forth between the representations. So 24 minutes, we're approaching 25. All right, that seems to be my standard length for our videos. Get headed over to your homework and make sure, remember, you're always copying problems down and you're showing your work. If you make a mistake and you did all the work in your head, you have no idea what you did wrong. Correct your mistakes and you will learn. If you don't correct your mistakes, you're going to keep repeating your mistakes. All right?